Another important register we have in execution unit is that flag register. In the flag register, you can see the directional flag, interrupt flag and trap flag. These are control flags and remaining all are conditional flags. Let us go through one by one. Interrupt flag. Interrupt flag means that you are always connecting a peripheral devices to the microprocessor. If you are connecting the peripheral devices to the microprocessor, it will treat as an interrupt. So, 8086 is to recognize the external mask interrupts. Maybe you can enable the interrupt as well as disable the interrupt. So, for that purpose, interrupt flag will be efficiently used. Trap flag. While debugging the program, we are generally going for two types of debugging techniques. One is single step debugging and another one is multi-step debugging. In single step debugging, as a novice engineer, we always try to see the result of every instructions. So, step by step tracing we have to do pressing the F7 or F7 switch in the TASM software or MASM software. Then you can see every instruction how it performs. That is called single step debugging. In multi-step debugging, we have some run button will be there. After pressing that run button, you can see the entire result after fetching the entire memory locations. So, trap flag will be used for a single step debugging and multi-step debugging. If this flag is set, the processor enters into the single step debugging. So, tracing the errors will be possible by a single step debugging. If a flag bit is 0, then it is obviously takes the multi-step debugging. So, you can see the each and every execution of the instruction, what are the things happened in that. Coming to the directional flag, particularly directional flag used for string manipulations. Let us understand with the example. This is the data segment and this is the extra segment. For a data segment, we can use the SI as used of an offset. For extra segment, DI can be used as an offset. Particularly for string manipulations, what happened? The memory location is going to be incremented automatically at the data segment side. And using the DI, you can automatically increment the memory locations for string manipulations. If directional flag is set to 0, the string is processed from the beginning, from the lowest address to the highest address. So, from the lowest address to the memory locations is going to be incremented in a data segment side and a extra segment side. If directional flag is set to 1, that will be starting the value from higher segment to lower segment value, means that auto decrement mode. So, to increment the address as well as to decrement the address, we can use the SII and DI are the offset values which will be used for string manipulations. Particularly, this will be helpful for multi-processor configuration and multi-programming purposes. Some of the segment bases can be overlapped. Let us have a look. This is the segment 1 and this is the segment 2, this is the segment 3 and this is the segment 4. Linearly we are connected continuously, but in sometimes what happened, the segment may be overlapped. In this point of view, what happened, the SI can be incremented from lower side here and as well as from lower side here, as well as the starting value will be saved at here and saved at here, so that the overlapping phases will be avoided by auto incrementing and auto decrement mode, particularly for string operations and from the move block of the data. It is directly helpful in the programming purposes. So, directional flag will be used for that purposes. Let us come to the overflow flag. This flag is set if an overflow occurs. That means that if the result of signed bit operation is large enough to accommodate in a destination register, overflow flag will set. In case of 8-bit register, the MSB bit is a signed bit, so that from 0 to 7 bits, like 2 power from 0 to 7 bits, so last bit is maybe signed bit. So 0 to 6 means that 2 power 7 plus minus 1 to 2 power minus 7 minus 1. So the upper range value and lower range value, beyond this value it doesn't exist, and if it reaches the beyond the value, then overflow flag will be occurred for 8-bit operations. For 16-bit operations, 2 power 15 plus 1 and 2 power 15 minus 1 minus side. So plus side and minus side, if it reaches the beyond the value, then overflow flag will affect for 16-bit operations. So if it reaches the beyond the value that we specified, then overflow flag will affect. sign flag. Sign flag means that the last MSB bit is 1, that means the sign flag affected means that is a negative number. If sign flag is 0, that means the unsigned number. So when the result of any computation is negative, then a sign flag will come into the picture. 0 flag. Particularly if you are doing some subtraction like 10 minus 10, the answer will be 0. If the result is 0, then this flag is going to be set. The result of the computation or comparison performed by any instruction, the value is 0, then 0 flag will be affected. Now another flag bit is parity flag. This flag is set to 1 if the lower bit of the result contains even number of ones. For odd number of ones, it is set to be 0. Suppose if the number contains even number of ones in the result, then this flag is going to be set. Means that flag is 1. If the result contains odd number of ones, then this flag is going to be 0. So the lower bit of the result, particularly the lower bit of the result contains even number of ones, then it is a flag is going to be 1. Or else for odd number of ones will be provided in the result, then the flag bit set to be 0. Auxiliary carry flag means that from we have a nibble, means that 4 zeros we have. In case while adding the two numbers, the carry will be propagated from third bit to fourth bit. It means that this is 0 first bit, 0 bit, 1, 2, 3 bit. If the carry propagated from third bit to fourth bit, then auxiliary carry flag will be affected. That means that this is set if there is a carry from the lower nibble, means that bit 3 during the addition or borrow from the lowest nibble during the subtraction. While addition operation, if you are performing from the third bit to fourth bit, if carry propagated, that is called auxiliary carry. During the subtraction also, if the borrow will be occurred from third bit to fourth bit, that is also treated as a auxiliary carry flag. Carry flag means that if this flag is set when there is carry out of the MSB in case of addition or a borrow in case of subtraction. While performing the addition operations, sometimes the carry propagated from 7th bit to 8th bit, then the carry flag is going to be set. Let us have a look at example here. This is the example 101000 and 1000, and this is 0100 1000. If I add this 0 plus 0 0, 0 plus 0, 0 plus 0, 1 plus 1 0 and carry 1. So 1 plus 0 1, 0 plus 0 0, 0 plus 1 1, 1 plus 0 1. Here in the result, this is not a 0 because I am adding here. So I am adding two numbers. The result is not going to be 0. If the result is not 0, then we can notice that 0 flag is equals to 0. 0 flag is set if the result or computation of the comparison performed by an instruction is 0. So if the result is 0, then flag is set, but it is not 0, so that 0 flag is going to be 0. And here what happened, the carry will be propagated from third bit to fourth bit. 1 plus 1 0 and carry propagated from, so 1 plus 1 0 carry will be propagated from third bit to fourth bit. This is called auxiliary carry. So auxiliary carry flag will be set. And 1 2 3 ones are there in the byte. So if 3 ones are there in the byte, then odd parity will be happened. So odd parity flag will be 0. You can see the parity flag. If the number of ones are odd, then parity flag is going to be 0. And carry flag, if the carry is provided, then suppose let us take this is 1 plus 1 0 and carry will be provided, that means that carry will also be provided. If it reaches them beyond the value, means that all the things are 1 and another 1 will be provided, that means that it reaches the beyond the value, it reaches the maximum value, then overflow flag will be affected. So if MSB bit is 1, that means the sign flag, means that negative number. If MSB bit is 0, that is the unsigned number. Like that you can see the behavior of the outcomes or behavior of the result by seeing the flag register. After performing the arithmetic logical operations, the information will send to the flag register. From the flag register, you can observe the behavior of the result, whether it is 0 flag affected, auxiliary carry affected, overflow flag affected, parity flag affected, and maybe the control flags affected. Like that you can see the entire behavior of the particular program during the execution.